In this lecture, we are going to look at addition of halogens to alkenes, which is called halogenation of alkene. Now, for instance, let's say this is a hypothetical alkene given to you. Let's say you have something like this, double bond, C, let's say you have something like this, C, double bond C, and then you have this group here, and then react it with a halogen like bromine. What do you think will be the product of the reaction? It's going to give us C, then we have C, the double bond will break, bromine will attack here, another bromine will be here, and then we have the bonds. Now, how does this reaction take place? Now, the reaction takes place via the following mechanism. We have this, which is the alkene. Let's say it could be any of the alkene given to you. The first thing you do is to express it in this form. Then plus the bromine molecule is something like this. It has a bond in between. Then you have the electrons on bromine. Okay. Now, what do you think happens? We said this double bond here is a perfect nucleophile. Now, if this double bond here attacks this bromine here, if it attacks the bromine, what do you think is going to happen? As it's coming to attack the bromine, this one here takes away the electron and then the bond breaks. Now, this is going to form what we call a brominium ion. Okay, so how does the brominium ion looks like? It looks like something like this. You have the carbon, okay, and then you have B arrow positive, because the bromine coming in here is positive. It will become positively what? Charged. Okay, and then you have this, and then finally you are going to have this, and then you have this and this. This is a linkage. This is what is called the brominium ion. Okay, in a situation where, let's assume, now I was saying, how about if here were to be hydrogen and, sorry about that, if here were to be hydrogen and here is CH3, and then here is hydrogen and here is hydrogen, it means here will be what? Hydrogen, and here will be CH3, here will be hydrogen, hydrogen. Same thing particular here. Here will be hydrogen, here will be CH3, here will be hydrogen, here will be hydrogen. That was what I was trying to explain, that it could be anyone. Are you getting it? Based on what is attached to each of these corners. So this is hydrogen, and then we have CH3, and then we have hydrogen and CH3. Now something happens. Now this bromide ion that is given off here is going to form something here. It's going to form this bromine. Then you have the lone pairs of electrons, okay, then negatively charged. Now what will happen is that this one will come and open up this ring here. So you have double bond here, double bond, negative charge. If it attacks here, what happens? This bromine here will break up, and then it will form, this double bond, this bond here will break here. And you know, when this bond is breaking, it's going with electrons, which is negatively charged. So that negative and this positive will neutralize. There will be no bond here, and then this positive will no longer be there too. Are you getting it now? So at the end of the day, what are we going to form? We are going to form something like this. It's going to look somehow, but I'm going to try and arrange it in the best way you can understand. So this carbon, you have this carbon here, right? Then what are you going to have? This bond is no longer here. Of course, you know, hope you know. This bond is no longer here. Let me just use this to illustrate. It's no longer there. Then it means that this hydrogen will be on top here, right? Now, if the hydrogen is on top, now what do we have here? We have the CH3 will be here, right? And then this bromine is coming here. It's going to form a bond between here. So we have the bromine here, right? And then we have C. Now recall that this bromine is coming this way, right? As it's coming here, there's a bond between this carbon and this bromine here. So that carbon bromine bond will still be there, or bromine bond will still be there. So it's going to form bromine. Are you getting it? And then you are going to have hydrogen and CH3. So this is the product of this reaction, okay? And that is for this reaction, electrophilic addition of halogens to alkene. the addition of halogens to alkene, electrophilic, yeah, electrophilic. So that is the product of that reaction. And that is the step 2. We've already written step 2 here. Say the bromine ion open the brominium ions, or the bromine ions open the brominium ion, which is what we did here in this step, this particular one here. So from here to here is our step 2. Okay, and that is everything you need to know about this. Okay, so let's try one more example. Let's use this other slide here to try one more example. For instance, let's assume you have an alkene given to you like this, CH3, then we have CH, double bond, CH, CH3. And then they say write the mechanism of the reaction. Between this, let me take it upward. Write the mechanism of reaction between CH3, CH, double bond, CH, CH3 plus HB, not HBr, plus BR2. Write the mechanism. When this react with this, it's going to form a product. Now write the mechanism. Now the first thing you need to do to make things make sense, take this carbon bond out. Carbon bond. What is attached here? Hydrogen, right? What is attached here? CH3. So you have CH3 here, right? What is attached here? Hydrogen. What is attached to the hydrogen? CH3. So you have CH3 here. Are you getting it now? So the first thing is the bromine ion we attack. We have this one. I don't want to start putting each of the electrons, but you know this one has 6 electrons around it. Okay. Then what do you think happened? We said this double bond here will come, pick this group here. This one will pack up here. Chap. And then it's going to form the brominium ion. Are you getting it? The brominium ion. The brominium ion is something like this. C. Now we say this double bond will break, right? And then you have carbon. This bromine that is coming here is going to form a linkage between this and this. So we have a positive charge here. Okay. Then of course you have this hydrogen here. So those are the reactions are very easy. If you can draw one reaction and understand how the arrows are moving, you'll be able to draw as much reaction mechanism as possible. Then this is CH3. Okay. Now the next thing we are going to look at now is how to break this bond. Now we said the other brominium ion will come and attack. We still have the electrons around it. If it attacks here, this bond will break and pack on top of here like this, right? And then we say the final product of this reaction would be something like this. C. Now recall that this brominium ion now, we say when it's coming here, it forms a negative charge. Negative and positive cancel, so there's no charge here. This becomes Br, right? And then we have CH3 under, which is CH3 here. And then you have what? The hydrogen, okay? And then here, you are going to have hydrogen. Here will be CH3. And then here will be the B arrow that is coming. And this will be the product of the reaction. So you see how easy it is, right? To undergo a reaction like this. Thank you very much for your time. So if you want to practice more, you can actually give yourself any of the alkene and then work with it and see what the product will be like. Thank you.